Oh, we're good.
Ready?
Thank you.
All right, you guys want to see a magic trick?
Yeah.
Okay. What if I told you I could make this paperclip float just using the paperclip, this magnet, some string, and some tape? Who thinks they know how? Who thinks they know how I can do this? Anybody have any guesses on how I can do this? Yes, Chelsea.
I think you're going to use the magnet over the paper clip to make it float.
Over the
Yeah,
paperclip?
I think you're going to hold the magnet over the paper clip.
Yeah. Okay. Well, cool. Okay. So as we can see, look, the magnet is attracted to the paperclip. See, it sticks to the magnet. See that there? All right. So let's see. Let's see. So what I did here is I taped a piece of string here. Everyone gather around and see this real quick. What do you think? Does anybody see this? Everybody see it?
Do you actually want people getting up?
I don't know. Can everybody see it from where they're sitting?
That's probably
It's
better.
tiny. So. All right. So I taped a piece of string here to the table. Okay. And I tied that piece of string to this paperclip here. All right. So how do you guys think I can get it to float?
Cantrell.
Put the magnet over the top. You guys want to see?
Mm-hmm.
All right. All right, here we go. Wait for it. Oh, wait. All right. Why do you guys think the magnet fell whenever I did that?
Because the magnet wasn't touching the paper. Too far away.
It was too far away? Okay, so it's too far away. That's a good guess.
Maybe the paper clip isn't like strong enough.
You guys see that? It's kind of hard to see.
I wonder if you could do that in the Elmo.
That's
What's
what
that?
I would have done. Yeah. Taped it to the Elmo board.
But yeah. All right, so what made you, so was there anything in between the paperclip and the magnet whenever I did that? Nothing? Nothing at all? Air. There was some air in between that. All right. So what you're telling me is that even though there's air in between the magnet and the paperclip, that it still pulls the paperclip towards it. What do you guys think? Do you think if there's anything else in between the paperclip and the magnet, do you think it would still pull? Like, what if I put this piece of paper in between the paperclip and the magnet? Do you think that it would still be attracted to it?
Yeah.
Yeah. Let's see. Let's see. If I put a piece of paperclip on here and a magnet, let's see. Look at that. So the force of the magnet still works through the paper here. So it still pulls the paperclip around.
Now, what's going on here?
He's giving it away.
You're giving it away?
So you're doing some explaining.
Oh no.
What's a concept? We're just good. Again, this is going to happen. What is a concept class that he just used that he probably, and this is first, second grade, that he probably is not going to want to use in Engage? Force. Anything else? Attract. We need to talk about attract.
Okay.
We need to talk about that.
Difficult?
I don't know. I need to email the teacher to see if they've used it.
Well, and I know in like our IQ, we took out the first attract, so we wanted to put in pulled. So we were thinking maybe if we said what objects are pulled towards the magnet and does the attraction, maybe they could connect the pulled and attraction.
Okay.
So we left one, but we weren't sure. Guess we'll see.
We'll think about that. Yeah, we'll think. Is it like a pretty big deal? Do you really want us to focus in on, you're asking us, will it still work through the piece of paper?
Yeah. Like
Is that a big deal?
I think because the experiment goes on to talk about like putting pieces, putting like through plastic or through paper.
Right.
So the focus is on the air in between, the material in between
Right.
the magnet.
So how can you make that exaggerate it so we're really focused and it's a really big deal? Even have a student come and hold the paper and everybody look, and you could ask, okay, who agrees or disagrees? Do you think it's going to work through the paper? And get everybody engaged.
Yeah. Okay.
Try it again. Do it again.
All right. So who wants to volunteer real quick? Who wants to help me out? All right, Chelsea, you want to help me out real quick? All right. Want to grab that piece of paper for me? All right. Hold on to this paper clip. All right. So let's see. Put that paper clip on top of the paper here. Now, raise your hand if you think that this magnet can pull that paper clip from between the paper. Raise your hand if you think so. Let's see.
Wait, stop. Wait. Make it even bigger. Okay. Now, who thinks it's not going to work?
Okay, so who thinks it's not going to work? All right, Erica, why do you think it's not going to work?
Because that paper is pretty big, so
Okay,
I think
that's a good idea. I like that. Yeah. Who else didn't think it was going to work? Who else doesn't think it's going to work? What do you think, Caitlin?
Because it's not touching, so I don't think that is.
Oh, true. So I wonder if they would work if it wasn't touching the paperclip. All right. Well, let's see.
Okay, so ready. Three, two, one.
Oh man, look, it worked. Okay, cool.
Now move it around.
Move it around. Look at that.
So what are we doing here, guys? Class? Why are we making it so exaggerated?
So they stay focused and yeah, they're interested in it. They're not sitting there bored.
All right. Cool. All right. What do you guys think if we put like 10 pieces of paper in between the magnet and the paper clip? No? Why do you think? Why do you think, Taylor?
I think you're going to need a bigger magnet.
Bigger magnet? Interesting. Okay, well, we'll talk about that later on in the explore stage. We'll see if we answer your question, okay? All right.
Hey, let's talk about what Patrick just showed us. Can I ask you something real quick? Is it important to include vocabulary before you present the IQ? Or should you always have the IQ in vocabulary that you already know?
It really depends. We can talk about it, yeah.
So Patrick used tape and string and a paper clip. What else did Patrick use?
Magnet.
Can somebody come up and draw a magnet for me? Thank you, Caitlin. Okay. So the magnet was pulling the paper clip, and this pull has a big word. We call the pull attraction. Guys, say attraction.
Attraction.
Okay. Jenna, can you come show me? Can you circle where the attraction is happening? Do you guys agree or disagree that that's where the attraction is happening? Thumbs up if you agree, thumbs down if you don't. Here's that long thumbs up. We have another word that we're going to talk about, and those are the objects that Patrick used. An object that you use to create something is called a material. Say material. Material. Okay? So tape would be a material. Alston, can you come circle another material for me? Right? String is a material. A paper clip is a material. What about the area where the attraction is happening? Do you guys remember what that is called? Attraction. But is there anything between the magnet and the paper clip? Is there a material?
Air.
Air. Very good. Do you guys agree that air is between the magnet and the paper clip? Thumbs up if you agree, thumbs down if you don't. Very good. Okay. So, like Patrick was showing us, magnets can work, what am I trying to say? Through other materials. It can work through air, and it works through paper. So we're going to talk about what else it can work through.
Okay, you guys pass these out. We're going to pass out a prediction that now we're going to make. We're going to give one to each table. So you guys need to do this as a table, talk it over, write it down, and then we'll talk about it as a class. First, our investigation question was what objects are pulled towards a magnet, which we discussed, and does the attraction happen in material other than air, which we've also went over. So now you guys need to use the investigation question to write your prediction. I think, whatever you think, because I saw. So it needs to go with the investigation question. So talk amongst your tables, and then we're going to talk about it as a class and discuss exactly what we think. What do you guys think? Just
Do you have any extra ones?
We don't.
Oh, okay.
we just have one per table, so do it as a table.
We're not extra, so.
We only need
So,
like
yeah, the parent.
Alright, it's gonna say I
So I think
Alright, so
the
you
objects
guys,
that are
you guys
pulled towards the magnet have to be like
A paper clip?
of a paper
they know exactly.
metal object.
So do you think it has to be metal? You do?
Okay.
So this won't pull towards the magnet. Why not?
Because it's this part right here.
So only metal's going to pull towards the magnet?
Because
Okay, you guys have any other ideas?
Do you think it would attract to the plastic?
We'll have to test that out.
But what kind of,
Yeah.
That's part of it too.
that's part of it, because it's a magnet.
What we found.
It's kind of like it's kind of like two. So we're gonna first say what objects are pulled towards the magnet, which she was saying, and then does the attraction happen in other materials other than air? So she was saying yes, it only happens in metal, and then what other things would happen other than air? Such as Patrick was already kind of like with the paper or
anything?
and objects, yeah. What do you guys think about
metals work?
what
Because
about
my mom's magnet still sticks to her refrigerator at home.
water?
You need to revise your IQ. That's good.
So think about that, and then talk it over a table, and then write down your prediction.
I think that since a paper
So that's why I didn't know what kind
things
of
that are made out of metal.
materials it was, but I know it will slow down paper because we saw Patrick demonstrate that it was with the air and paper.
Do you think that her watch would be attracted to a magnet?
See, this is a good question.
You know when you hold the magnet up to
I have no questions, but I have predictions.
Small objects, like anything.
I wonder if all metals are attracted. Let's test out.
Ongoing experiment over the next year or so. And then what about
Do you think
You're like
that
kind of
if
teaching.
we put a paper clip inside your water bottle and have a magnet outside, that it would pull through the, you think that it would be attracted still? Think it was thin enough? Yeah.
I think so.
Why do you think? It's a good idea.
Nice and strong.
I know it's like
Cool.
okay, does everybody have something written down at their table? Give me a thumbs up if you do. Alright. This table back here, what did you guys write? What was your predictions?
we wrote, I think that a paper clip is attracted to a magnet because it is made of metal.
Okay. Okay, now with that paper clip, so only a paper clip will be attracted to the
Or
magnet?
anything that's metal.
Anything that's metal. Does anybody agree with her or disagree? Richmond?
What do you
Agree or disagree?
I agree.
You agree? Does anybody disagree? Yes?
I disagree because my mom's magnets don't stick to her refrigerator at home.
They don't?
And our refrigerator is metal.
Wow, that is a really good observation.
So I wonder if all kinds of metals are attracted to magnets, or only if certain kinds. What do you guys think?
Well, I think only certain kinds are because it's a metal fridge. The magnets don't stick.
Why don't you write that down so you remember it? And then later on in the experiment, we can go back to that question and we can all discuss that as a class. Okay, now what about through other materials? Patrick already did one through paper. But what about any other materials? Do you guys think that it will stick to any other materials? Any ideas? Yeah.
We thought that if it's thin enough.
Thin enough? Okay, so maybe this paper cup. That's pretty thin, don't you think? Possibly. Any other ideas? Yes.
We said that if we put the paper clip in Ryan's water bottle, that the magnet would still attract it because water is so thin.
Good idea. You guys have great ideas. What about this table over there? Do you guys have any ideas?
I didn't think the magnet would attract to the paperclip when it was in the water bottle because the plastic will stop the pull.
Good, good. All right, so what we're going to do is we're now going to do an experiment. Well, not really, but later on. And we'll find out. That's it.
Yay.
Great. Good job, guys. What were some of the effective teaching moves that you noticed they used?
Oh, here's this one.